When we were looking at the earned value management parameters, we were very much interested in the evaluation because we want to understand when our project is expected to finish and how much the project will cost at completion. We have the earned value parameters, the planned value, the earned value, the actual cost of our project at a certain moment in time. We also know that there is a budget at completion, and basically from here we're in fact going to use those parameters to estimate where will our project end. In order to do that, I start with a small schedule here where I have the S-curve, the S-curve over 10 periods with a budget at completion of 250K. We have a line, a linear evolution of the S-curve. It's easier for our calculations, for our extrapolations. Now, first of all, we find at period 5 that the planned value was 125K, which is basically in the middle. So we have 125K that was expected to have been reached at the 5th period. Now, here we see what we expect as a cost, plus also as deliverables. And related to deliverables, we have to see how many deliverables did we create and what's the earned value of those deliverables. So the earned value at this moment is 95K. Basically, this gives us the indication that we are behind schedule. The third parameter is the actual cost. The actual cost we compare with the cost of the value of the deliverables that we created, and we see that we paid more than the value of those deliverables, which is basically an indication that we are behind schedule. So our project is not so nice in this case, but we see that we have these different parameters here, and we can start working with those parameters to do some calculations. Now it's good to review the elements because in the last presentation I asked you to calculate the CPI, the SPI and the CSI and put it in the comment field. So here we're going to start by calculating those parameters so you can verify if your solutions were correct. Now let's start with the SPI. The SPI is the indication for the schedule performance index. The SPI is in fact earned value at everything at period 5 divided by the planned value at period 5, which is in fact earned value is 95 divided by the planned value is 125, which gives me an SPI of 0.76. When you would do these calculations, it is possible that you have more decimals there, and there may be some small rounding errors that you may encounter. Now let's calculate the CPI. The CPI also at period 5. We have the definition of the CPI is the proportion of the earned value at period 5 divided by the actual cost at period 5, and we replace this by the values. So we have 95 divided by the actual cost, which is 110, which gives us a value of approximately 0.86. So these are the SPI and the CPI values, and based on these we can now calculate the CSI. The CSI, which is the product of those two. And the CSI at period 5 is SPI at period 5 minus the CPI at period 5, which is 0.76 times 0.86, which is approximately equal to 0.66. So if you found the same numbers in your calculations, then you did the calculations well. Let's continue and see where we end up when we extrapolate the evolution that we've seen here, that we extrapolate these values to determine the end time of the project and of course the cost, the estimated cost at completion. Once I calculated the SPI, the CPI and the CSI, I will be able to integrate them in some formulas to calculate the expected or the estimate at completion. What will be the end cost of our project? Now, we can try it in another way, and what I did here, I extrapolated the earned value curve, which means that I assume that the relationship between the planned creation of deliverables and the actual creation of deliverables or the creation of earned value is going on in the same proportion. Basically, this is a line with a slope. I have the rise divided by the run, which is the slope of a line. And in our case, this is 19. So the slope of this line is 19. And we can say that the earned value over time as a function of time is the slope times the time. Now, what happens when we continue working on a project? We continue creating deliverables until all deliverables have been created. And that gives us the indication where I have to stop. How can I find the end time of this project? Well, I continue creating the deliverables until I reach the budget at completion, because the budget at completion is basically the value of all the deliverables. So when I create all the deliverables, I earned the budget at completion. And basically that gives me the duration of the project. Now, what I do at this moment is that in this point, the earned value is equal to the budget at completion. We know the slope and the time is still not known. So when I divide, in fact, the budget at completion by the slope, I find that the end time is in fact 13 periods. Our project will be finished in 13 periods. And that's the first parameter I have to use. The second assumption I make is that I'm creating the deliverables with the same efficiency or the financial efficiency. So with the same CPI. It means I extend this line until I finish the project, and I finish the project here. Now this equation is again the equation of a straight line, and I can say that the actual cost as a function of time is the slope multiplied by the duration. And the slope for this line is the actual cost in period 5 divided by the time. So it's basically this triangle I'm considering, which is 110 divided by 5 is in fact 22. And what I can do now is that I continue, because in the time here in period 13, I know that the actual cost or the estimate at completion in this time will be equal to the slope multiplied by the time is in fact approximately 286K. This is a simplification of how to find the estimate at completion. And we will see in the next part, when I go and have a look at the formulas, we will see that this is exactly one of the formulas that we will define in earned value management, and we can find it quite quickly, easily, looking at those equations of those two lines. Those who don't like mathematics so much, you can skip the next part, but I think it's quite interesting to see how we use linear algebra, linear mathematics, equations of straight lines to find that equation. It's only a few steps, and when you remember how these things are going, you can remember these formulas a lot easier. You don't have to learn them by heart so much because you find the logic. But everybody studies differently, so if it's interesting for you, have a look at it. Otherwise, you can go to the next part of this video just by clicking on the menu in the description. Based on the previous drawing and the formulas, the equations of the line of the earned value as a function of time and the actual cost as a function of time, we can derive the formula to get an estimate at completion. It's one specific estimate at completion that we can derive very quickly from these formulas. We start from the expression of the earned value as a function of time. So we know the slope is earned value divided by T1. So the earned value at the time T1 multiplied by the time. And we find the end time when the earned value is equal to the budget at completion. And that's the end time, so we can start from this formula. So this is the starting point, and we bring this in this equation. So basically we fill out, or we change, estimate at completion is now AC1 divided by T1 multiplied by T end, and T end is budget at completion times T1 divided by EV1. And what's very nice to see in this equation is that automatically we can eliminate T1 because T1 is both in the numerator as in the denominator. Now we adjust this a little bit and we say that we have the budget at completion is equal to the back divided by EV1 divided by AC1. And we know that this parameter is the CPI. So we can write here that the estimate at completion is in fact the budget at completion divided by the CPI. And we take in this case the CPI at T1, so I call it CPI1. And this is in fact the way we can find this equation very quickly. So we find the end time, we replace it in the expression of the actual cost, and basically we find a very simple relationship where the estimate at completion is equal to the budget at completion divided by the cost performance index. And that's one of those equations that we will find later again when we are looking at the different equations, when we are defining all the different estimates at completion. Okay, so we did some calculations. Now we are going to look deeper into the different estimates at completion that we can define and that are defined in earned value management. The first is the estimate at completion by the project manager. Now the project manager is the authority related to the project. And we always have to take his or her estimate very seriously. Now, in our case, we said that the estimate of the project manager is 255K. But is that correct? And do we have some means to verify this? Well, the first thing we're going to do is to look at some other estimates. First of all, we are looking at the mathematical estimate at completion. And the mathematical estimate at completion we can write as, this one, is in fact the remaining deliverables that we still have to create will be created with an CPI equal to 1. It means that the cost to create a deliverable is equal to the cost that we estimated. Now, first of all, we have to know what is remaining. Remaining at T1. How much deliverables do we still have to create? Well, basically we have to look at, first of all, the budget at completion is the value of all the deliverables that we have to create to complete the project. Now at T1 we already created a number of deliverables, and the earned value of that number of deliverables that we created is in fact already a part that has been done. So the remaining part is the back minus the earned value at time 1. So this is the remaining value that we have to create. What we did in the past we cannot change anymore. So we start with the actual cost at period T1, and we have to add the remaining value that we can earn. And in this case it's the back minus EV1. So basically here we have the CPI equal to 1. That's what we already did. That's the amount of money we paid to create this earned value. But the back is the total value I have to earn to complete the project. So the back minus the earned value is the remaining value of the deliverables that I still have to create. And this is what I call an optimistic value. An optimistic estimate. Now the second element that we're going to look at is the estimate at completion CPI. And we start again with the actual cost. And now what we assume is that the remaining deliverables will be created with the same financial efficiency. It means that we're creating them, but the CPI will be equal to the CPI from the past. So we can write this as back minus EV1, and that divided by the CPI, which is the probable estimate. The probable estimate. And the last element that we're going to do is in fact the last one, where we have the factor CSI. So the estimate at completion CSI is again AC1 plus, and now we assume that the efficiency for the remaining part will be equal to the CSI. And we can write this as back minus EV1 divided by the CSI, and we call this a pessimistic estimate. So these are in fact the three different estimates that we can calculate, and of course we have the estimate at completion given by the project manager. Now there is one thing I want to show. In the previous calculation we calculated the estimate at completion. We found a formula, and what I want to show you now in a few seconds is that this formula is in fact the same as this formula. In the last calculation I want to show you that the formula we found by extrapolating the lines in our graph and using the equation of a line, we found back divided by CPI as the estimate at completion, that it's equal at the estimate at completion with the CPI. Now what we have to prove is the equality of those two. Now we know that the CPI is equal to the earned value over the actual cost. So we replace the CPI. CPI is earned value over actual cost, and we find the equation actual cost plus back divided by CPI minus EV divided by CPI. And now I replace the CPI in this part, not in the rest, it's not necessary, by its expression. So I find here actual cost plus back divided by CPI is earned value divided by earned value divided by actual cost. And when we look at this, we can simplify. So this is 1 and 1. So we find, oh, this has to be minus, actual cost plus back divided by CPI minus actual cost is the final result. And I can say these two eliminate, and I find that this is equal to this. So basically, for the estimate at completion with CPI, we have two formulas we can use. We can use the very simple formula, which is the back divided by the CPI, or we can use the more complex formula where we have AC plus the remaining value to earn divided by the CPI. So both formulas are equivalent, are basically the same, and you can, of course, use either one of them. After identifying all those different estimates at completion, we now can apply what we've learned before on our example. Our example has a planned value at period 5 of 125k, an earned value at period 5 of 95k, an actual cost on period 5 of 110k, and basically we know that the budget at completion is 250k. The project manager gave us an estimate of 255k, and we want to know if this value is correct, yes or no. So first of all, we start with some preliminary calculations which we will be using in the presentation. We have the back minus the earned value at period 5 is basically 155k. That's the value of the deliverables that we still have to create, and that's the remaining value we can earn. Now let's put that in the first equation where we have the mathematical estimate. Here we are going to assume that we continue the creation of the deliverables as planned. Let's say that the cost of the creation of the deliverables is equal to the actual cost to create them. It means that the cost performance index is equal to 1. Let's have a look here. Actual cost of 5 is 110k plus the 155k gives us a 265k as a final estimate. So that's the mathematical estimate. Don't forget, the mathematical estimate is also the optimistic estimate. The second estimation is the CPI-based estimate at completion. Here we do the extrapolation and we suppose that we continue creating the deliverables with the same cost performance, and we find again the same is the actual cost at period 5 is again 110k, but now we have to divide by the CPI, and we find 155 divided by the CPI, which is 0.86, which gives us a total value of, and herefore I need my calculator. My calculator is 155, enter 0.86, divide, and 110 plus. When you wonder why I'm saying enter and things like that, I'm using the Hewlett and Packard RPN reversed polar notation method to do the calculation, which I've been using since I was 18 years old. So we find here that this is 290k approximately, because it depends a little bit on the roundings that we use when we do these calculations. So there may be sometimes some small differences, but they should remain small and they should not have an effect on the final evaluation of the status of the project. Now the last one is the estimate at completion with the CSI. This is the pessimistic estimate. This is the highest estimate that we assume. So basically the actual cost is still the same, 110k, but now we have the remaining earned value to earn at the CSI as efficiency. So we have to divide by 0.66, and we find, let's go back to the calculator, and I find approximately 345k. So basically what we find here are three estimates: an optimistic, which is the mathematical estimate, the probable estimate, which is the CPI based, and the pessimistic, which is the CSI-based estimate. Now the question remains, what about our project manager? Our project manager gave us an estimate at completion, which is equal to 255K. What does it mean? Well, we see that this is more optimistic than our optimistic estimate. And what we normally expect is that the estimate by the project manager should be between those two borders. That's basically what we expect. Now, in this case, we're outside. And when we're outside of these borders, we may ask the project managers for their reasons. So when the project managers give us estimates which are not between those minimum and maximum borders, we want to know why did they give that estimate. If there is a reasonable explanation, that's great. If not, we have to ask the project manager to review the estimate and to provide the explanation why we have that estimate. So basically what we've seen in this rather long video is how we came from SPI, CPI, CSI, and from the earned value parameters to an estimate at completion, basically to different estimates at completion. And that's very important to understand where our project is going, because we will use those parameters to evaluate the business case. Are we still compliant with the financial parameters of our business case? That's another story. We will talk about that later. Anyway, it was a very long and I'm sure very heavy video. Of course, you can review the things. You don't have to look at all the mathematical calculations. I just provided them to you to show the logic, how we find those formulas. And for me, of course, I have a little bit more mathematical mind than other people. It's easier to understand how we find these equations. And once I know where the equations come from, I don't have to remember them. I don't have to learn them by heart, because I understand the principle and I can find them by simple reasoning. Everybody has to do the things the way they like it the best. And of course, you will find your way. I hope this alternative way helps you. And of course, you can always give some feedback. You can ask me to get some other subjects on the video, or you can put some comments, ask some additional information about what we are doing. Anyway, you did a great job. It was a very, very long video, and I hope you enjoyed it, and I hope to be seeing you in our next videos. Thank you very much, and bye-bye.